Hello students, I am Dr. Akansha Srivastava, Associate Professor, School of Management, BBDU University, Lucknow. In this video, I will discuss a very important topic, normalization, which is there in third module of the course, Database Management System, and the course code is DSE 47103. So let's start with the topic. What is normalization? As we all know that in database we used to store the data in the forms of tables, right? So normalization is a process which used to organize a database to reduce redundancy and improve data integrity. There are 2 points basically. Number one, reduce redundancy. What is the meaning of this? Reduce redundancy? Reduce redundancy means there should not be any kind of duplicacy in the data. There should not be any repeated data in the system. Because if there is repeated data in the system, that means it occupies extra space. Extra space means it will certainly create the unnecessary cost. So we should reduce redundancy. And what is the meaning of data integrity? Data integrity means data should be complete, data should be accurate, data should be valid. So normalization is the process which ensures that there is no redundancy or very less redundancy in the data, and the data is complete and the data is accurate. So the basic goal or the basic aim of normalization is to make sure that data is stored efficiently and consistently. So I hope you can understand why normalization is crucial and why normalization is important when we are talking about DBMS. The 3 main points why normalization is important and why we need to normalize our data, actually I have already discussed. Same 3 points. Number 1, reduce duplicate data. It should avoid storing the same data multiple times. Number 2, improve data accuracy. It ensures data is consistent and reliable. And number 3, simplify update. Whenever we want to update information which we have already stored, it should be easy to update. So these are the 3 basic points why normalization is important and why it is necessary. Okay, the key concept of normalization, basically these are the different types of normalization. The first normal form, the second normal form, the third normal form, and the Boyce Codd normal form. We have more categories also, but in your syllabus there are only these 4 normal forms. So in this presentation we will discuss these 4 concepts of normalization. Let's move further. The first normal form. What is this, the first normal form? A table is in first normal form if all columns contain only atomic values. Simply you can understand it like in any column there should not be multiple values. Every column should contain single value, right? We will understand this concept with the help of an example. As we can see a table on the screen, and there are 3 columns or 3 attributes. The first column is your student ID, the second column is name, and the third column is courses. As we can see, the third column is carrying multiple values, and that certainly violates the first normal form rule. So we need to rectify it, right? Because this is a normalized table. We need to convert it into a normalized table. So how we can do that? Let's see. What we have done, let's see. In the first normal form version, each course is listed in its own row. Now you can see the course column has only single value. In the entire table, now there is no column which is containing multiple values. So it fulfills the first normal form condition. The first normal form condition is there should not be multiple values in any column of the table. So yes, this table is in first normal form. I hope it is clear. Now, let's move further. The second normal form. The very first condition for second normal form is the table must be in first normal form, right? After that, the second condition, there should not be any partial dependency in the table. Now, what is partial dependency? As we know, in table there is a primary key or possibly a composite primary key. Composite primary key means what? Where we combine 1 or 2 columns to make a primary key, right? Other than these primary key, every column or every attribute is known as non-key attribute, right? What partial dependency says that a non-key attributes depends only on part of a primary key, not the fully primary key, right? So we need to eliminate this partial dependency. It should be like all non-key attributes are fully functionally dependent on the entire primary key. So there are basically 2 conditions for second normal form. The first condition is the data or table should be in first normal form, and the second condition is there should not be any partial dependency. Now let's try to understand this with the help of an example. As we can see a table here, a combination of student ID and course is the primary key in this table, right? But the instructor column depends only on the course, not on the student ID, because the student ID cannot determine the instructor. So instructor is not dependent on the student ID, instructor is only dependent on the course. But the primary key is the combination of student ID and the course. So the third column, that is the instructor, or we can call it the non-key attribute, is partially dependent on the primary key. This is known as partial dependency, and we need to remove this partial dependency to convert this table into second normal form. How we can do that? Let's see. Yes, we have decomposed the initial table into 2 forms. You can see here. There is one table, is student course, which contains 2 columns, student ID and course, right? And the another table, that is course table, Again, it has two columns, course and instructor, right? In the first table, there is only student ID and course relationship, and in the second table, it is about course and instructor relationship. Now you can see, by decomposing the initial table, we have removed the partial dependency. Every non-key attribute is now fully functionally dependent on the primary key, right? So yes, this is in second normal form. I hope it is clear. Now the third normal form. So condition for third normal form is, it should be first of all in second normal form. The very first condition for third normal form, the table should be in second normal form, and the second condition is there should not be any transitive dependency. Transitive dependency means what? Any non-key attribute depends on other non-key attribute. This is known as transitive dependency. And in third normal form, we eliminate this transitive dependency. All non-key attribute must depend on the key attributes only, right? Now let's see. We try to understand this with the help of an example. Instructor phone depends on instructor, not directly on the primary key, and primary key in this table is student ID and course. It's basically a composite primary key, right? But because this instructor phone depends on instructor, instructor phone is a non-key attribute and instructor is itself a non-key attribute. So a non-key attribute depends on a non-key attribute. This is a transitive dependency. How we will remove this transitive dependency? Let's see. After decomposing the initial table into these three tables, you can see in all these three tables, every non-key attribute depends on a key attribute. So we have removed the transitive dependency. So this is now in the third normal form. The data is now in the third normal form because we eliminate the transitive dependency. I hope this is clear. So let's recall the first normal form. It removes the repeating groups. The second normal form, it eliminates the partial dependency, and the third normal form, it removes transitive dependencies, right? I hope it is clear. Now the last one, that is Boyce Codd normal form. For Boyce Codd normal form, the first condition is the table should be in third normal form. And for every functional dependency, for example, there is an equation x to y, where x is a determinant and y is the dependent, right? The left side of the column, the left side of the equation is known as determinant, and the right side of the equation is known as dependent. The left side of the equation, which is determinant, should be a super key always, right? Boyce Codd normal form says that dependent should always be determined by the determinant, and determinant must be a super key. If any determinant is not a super key, then it is not fulfilling the Boyce Codd normal form condition. So there are two conditions for Boyce Codd. Number one, the table or data should be in third normal form. Number 2, the determinant must be the super key, right? We know this boy squad normal form as 3.5 normal form also, right? Because it is the stricter version of third normal form. Let's try to understand this within example. Consider a university database with a table that records which course are taught by which instructor in which departments. We want to ensure that the table adheres to BCNF. Yes. The initial table contains 4 attributes: the course ID, course name, instructor and department, right? The first equation or first functional dependency, you can see course ID to course name and department. A course ID determines the course name and department, right? The second functional dependency is instructor will determine the department, because an instructor is associated with one department, right? Now what is the issue here? Try to check it out. The first equation, course ID to course name and department, right? Course ID is the primary key, so it is the super key, right? So here the determinant is super key. This dependency is correct. Now the second functional dependency, instructor to department. Here instructor is not a super key. This is the issue. So we need to resolve this issue to convert this initial table into BCNF. How we will do that? Let's see. And the department can be determined by the instructor, and instructor is the super key. So the condition for BCNF that determinant must be a super key is fulfilled, and now after decomposing the initial table into these 2 tables, we have achieved the boy squad normal form. I hope this normalization concept and all the types of normalization is clear. So first normal form, second normal form, third normal form and BCNF normal form. These are step-by-step normalization of the data, and I wish it is clear. These are certain references which I have used to prepare this presentation. Thank you.